Okay, so these are our objectives. We're going to review the exponent rules, and then the big thing that we're going to be doing today is multiplying monomials. We're not going to get to dividing monomials. Does anybody remember what we did in class on Friday? We also did it in class on Thursday. What did we do?
It was the note card.
What did we do on those note cards?
You were with the equation in, and then you put the x branded thingy with maybe you add them up and
Okay.
add them in order.
There we go. She said it very simply, adding and subtracting polynomials. So now we're going to move into multiplying polynomials, and prior to multiplying big, long polynomials, we're going to just multiply monomials to get used to the exponent rules. Dividing monomials we'll save for tomorrow, so we won't hit that at all today. Okay, first exponent rule, let me move this little thingy over, is zero exponents. Any number to the 0 power is 1. So if I have 3 to the 0 power, that equals 1. Evelyn?
You have notes?
No, you actually don't have notes because you have the quick reminders. And today's flip chart is not heavy on the notes. It's a bunch of examples, and you're going to do more examples on your homework. So you don't need the notes.
Write this down?
No, just give me your attention. All right, we're going to go through this pretty quickly too. So 3 to the 0 power is 1. If you had 100 to the 0 power, that would be 1. If you had any number, like even a variable like x to the 0 power, that's 1. I'll show you why that works when we do division in a few minutes. We're going to actually look at that today. Okay, so that's the first thing you need to know. Negative exponents. If you have a number that's raised to a negative exponent, what this means is you're actually going to take this number and write it on the bottom of a fraction with 1 as the numerator, and you're going to have positive exponent. So we're taking 3 to the negative power, we move it down here, and it becomes 3 to the positive second power. So to simplify this, we have 1 over 3 times 3 is 9. So 3 squared is 9. 3 to the negative 2 power is 1 over 9. Let's try another one. If we have 2 to the negative 3 power, this means 1 over 2 to the third power. 2 times 2 is 4, times 2 is 8, so we have 1 over 8. 2 to the regular third power would just be 8, but 2 to the minus 3 is 1 over 8. If we have x to the negative 8th power, how would we write that as positive exponent? Maddie, what do you think?
1 over x to 8.
Good, 1 over x to the 8th. What if we had something like this? Say we had, it's a different color, x squared y to the negative 2. How do you think you would write that? Nick, what do you think?
1 over x squared y to the second.
Not quite. Evelyn has an idea.
What did you say?
Just tell me your idea.
Okay. 1 over x to the negative second power y.
You actually, you could write it that way, but we want to get rid of the negative altogether. Maddie?
It would be 1 over x to the second y in parentheses and then to the second power.
There's no 1 in it. That's your first hint. There's no 1. We only need to move negative exponents. That's another hint.
Oh, so y equals 1 over y equals 2, or y to the second power.
No? This is the only thing we have to move. This one can stay. So we can leave the x squared on top and just move the y squared to the bottom.
And that's how it stays.
Let's try another
I'll
one.
write that.
What if I had x, y to the negative 2, z squared? What would that become?
Z squared over
X, y to
x,
the-
y squared.
X y to the power of 2 over z.
This is not x to the power of 2, it's x to the power of 1. The
Oh.
x is not included in this negative exponent. Only the y is included.
Then you put y to the power of 2 on the bottom.
Good. And what do I have left on top?
X to the power of 1 plus z to the power.
Not plus, this is all multiplication. So we just write z squared. Let's try one more. Let's do 12x squared y to the negative 3.
Put 12x to the second on top,
Mhm.
and y to the third on the bottom.
Good. Just have to move the one that has the negative exponent to the bottom. We'll do more practice with this in what we're doing today. Okay, multiplying and dividing powers with the same base. So in other words, say you have a power with the same base. So the base is 3 on both of these. We have exponents of 1 and 2. When you multiply, you're going to add the exponents. So we have 1 and 2
9 to the power of 3.
is 3. So it's 3 to the third power. This is like 3 to the first power is just 3. 3 to the second power is 3 times 3. And 3 times 3 times 3 is 3 to the third power.
Why isn't it 9 to the third power?
That's what I thought it would be 9.
It's not 9 to the third power, it's 9 times 3.
I don't get it.
Okay, I'm going to show you another example. Say I have x squared times x to the third. X squared means that I multiply x times x.
This is 1.
No, it would be, this is x squared. X times x is x squared. This is like taking this and factoring it out, okay? X to the third means x times x times x. So we have x times x times x times x times x. We have x multiplied by itself how many times? 5 times. So this is x to the fifth. That's why you add the exponents.
So you don't do anything with the big number.
Not in this case, you don't. Now, if you had something like, say you had 2x squared times 3x to the fourth. You don't have numbers that are raised, like you don't have the same base raised to different powers. These are just constants, just coefficients. So when you have a problem like this, you're going to multiply the big numbers to get 6. You're going to add the little numbers, or the exponents, to also get 6.
So confusing.
This part won't be confusing because we'll be practicing it a lot today. But let's try another one. The more examples you see, the more helpful it is. Say we have 4x to the third times 3x to the fifth. You're gonna-
12x to the 8.
Yeah.
So if the big numbers don't match, you multiply, and if they do match, you don't do anything.
Right. Well, eventually you would be multiplying, you'd be doing 3 to the third power. Most of our examples are going to look like this.
Okay.
Okay, when you're dividing, you're going to subtract exponents. So if we had 3 to the fifth divided by 3 squared, same base, different exponents, 5 minus 2 is 3. So that's the same as 3 to the third power. Another example, if we have x to the fifth divided by x to the 1, bases are the same, x is the base, we have x to the fourth. Good. If we had, I'm going to use a different color, 15x squared divided by 5x, we're going to divide the big numbers. So
3x.
15 divided by 5 is 3. And we're going
3x
to
to the
subtract
first.
x to the first. Good, or just 3x. You
Why
don't
do you
need to
divided
write
by
that.
1?
The dividing makes a little bit more sense than the multiplication.
Really?
Yeah.
Okay, one other little thing we're going to look at. I'm not going to look at everything on your sheet. I'm not going to do, I think it's 6 and 7. I'm not going to do today. I'm going to look at raising a power to a power. So if I have x squared to the third power, when we raise a power to a power, we multiply the exponents. So if I'm taking x squared to the third power, I multiply 2 times 3 is 6. The reason I do that, if I have x squared, that means x times x. If I have that to the third power, it means I'm going to write what's in the parentheses times itself 3 times. So I'm going to have x times x times x times x times x times x. There's 1, 2, 3, 4, 5, 6 x's all multiplied by itself. So it works out to be 6. We're not gonna do very much with this today. I just want you to see it, file it away for when we get to it again later. Okay, so don't worry too much about this. Big thing that we're gonna be doing today is multiplying monomials. This is where you multiply the coefficients, you add the exponents. So if I have 2x squared times 3x to the 5th, I'm going to multiply the coefficients. 2 times 3 is 6. And then I have same base, both x's. I'm going to add the exponents, so I have x to the 7th. I think that was a 5 there. Wasn't that a 5?
Mhm.
Yeah. I circled it and then I couldn't tell what it was. So we end up with 6x to the 7th. Okay, let's try this one. Nick.
Alright, so negative 12x
Add these. Add the
7.
exponents. 7. Okay, Mariah, do this one.
Negative 12x.
Good. Multiply 6 times negative 2 to get negative 12. Add the exponents 6 and 5 to get 11. Jada, this one.
7x.
Multiply
No,
coefficients.
12x.
12,
21.
to the 21st power. Good. Okay, any questions about this slide? Okay, let's look at this batch. This one has 3 terms that we're multiplying, but you just do it the same way. We're still going to multiply the coefficients. We're going to add the exponents. Evelyn, take a crack at that one. Mhm.
84.
Good.
X. And 6?
No.
31.
4 plus 5 is?
Almost minus.
Oh, okay. Just adding.
It would be 9, right?
Mm-hmm. And then 9 plus 11 is?
Mm.
9 plus 11 is
21.
No, it's just 20. It's 20. Because 11 is one more than 10, and 9 is one less than 10. So 11 plus 9 is going to equal 20. It's like 10 plus 10 would be 20. Okay, that's okay. That happens to us all sometimes. Okay, let's take a look at this one. This one has negative exponents, but you're still going to add the exponents. Only one of them is negative. So 2 times 3 is 6. I'm going to add negative 2 plus 5 gives me
3.
positive 3.
I get that one.
Not right now. Mariah, try this one. To the negative 5th. Now, we need to rewrite this one without a negative exponent. So how would I rewrite it?
12x is 1 over 12x.
No? I can keep the 12, because the 12 is
Okay.
to the first power.
12 to the first power
Uh-huh.
over x to the fifth.
Good. I just take the one that has the negative exponent, and I move that down to the bottom. Okay, let's do this one. Nick.
15x to the 4th power.
Careful, negative 8 plus 4 is? Negative 8 plus 4?
Negative 4.
Negative 4. Okay, how would I rewrite that without a negative exponent?
15 over x to the fourth.
Good.
Yeah. See what I need to do?
Okay, we have one more slide.
Why do you have to put it like that?
Put it like
Oh, my.
Because you're not allowed to have negative exponents. You have to, when you're simplifying polynomials, you have to get rid of your negative exponents. It's just a rule.
I don't like this.
Okay, these ones have multiple variables. You're just going to take variables that are the same and add together their exponents. So we're going to multiply the coefficients still. I have a 2 times 3
6.
is 6.
X.
I have a 2 as the exponent for this x, a 3 for this x. 2 plus 3 is 5, so I have x to the 5th,
Y to the 4.
y to the 4th,
Z.
not z. This is z to the 1, z to the 1. 1 plus 1 is 2.
Z2. Z squared.
It's z squared. Z squared. Okay, Evelyn, do this one.
15. X to the first. Y to the 8.
Good, and you put the x before the y, which is good. When we write individual terms, we go in alphabetical order like that. If you're writing alphabetical, so x comes before y in the alphabet, so you put the x first and the y. That's just standard, that's all.
This isn't English.
Okay, Jada, do the next one.
Alrighty. 8.
Mm-hmm.
X. -3.
Good.
And just fifth power.
Fifth power, good, because we have 4 plus there's actually a 1 here. Okay, now we have to get rid of only the variable that has a negative exponent we have to move. So what would that be?
8y to the fifth power over x to the third.
Good. Just this variable has to move.
I'm getting this.
Okay, Maddie, do this one.
Negative 18x to the 7th power. Y to the negative 2. Z.
Good, now rewrite it so there's no negative exponent.
Negative 18x to the 7th power. Z. Over y to the 7th power.
Very good.
So negative numbers don't count.
Right, negative numbers don't count, it's just negative exponents that count. Okay, now what we're gonna do, I'm gonna pass out your worksheet.
I know that.
We're gonna do a few examples from here so that you have some examples to look at. And I'm gonna keep recording it so that people who are trying this at home can have the same benefits.
Oh, fantastic.
Okay, so this is the multiplying and dividing monomials worksheet. It says geometry Burbridge at the top. I don't know why it says that. That's probably somebody's geometry class and they were reviewing algebra. But since someone made the worksheet for me, I took advantage of
Are we
that.
doing the back?
No, we're not doing the back today. Okay, let me go to a blank screen.
I have a question. If we did the back, do we get extra credit?
No, don't do the back because we haven't learned the back yet. So you can't do the back. All right, number 1, we're gonna do together. 7x squared times 6x to the 3rd. Lost my cards. I never had them to start with, I guess. Jada, tell me what this would be.
See here. 42x to the fifth power.
Good. These ones don't have any negative numbers, so you don't have to deal with negative numbers. Okay, next one we're going to do together is number 4. 5x to the 10th times 10x to the 9th times negative 5x to the 6th. Who wants to do this one?
Negative 250 x to the 45th power.
Good.
Yeah.
So we're just multiplying all the coefficients. It's good that you picked up on the negative, and then adding all of the exponents. Okay, we're also going to do number 5 together. Mariah, do number 5 for us.
18x to the 13th power. And then y.
Good. do number 9. Negative x to the third, y to the fourth, z squared, times 3xy to the fourth, z to the third. Evelyn did that one.
Oh my god. Okay. 3, no, yeah. 3 to, okay, 3 negative x to the fourth.
Okay, wait, it's not gonna be
Negative
negative x. Imagine that there's a negative 1
3.
here.
Okay, negative 3.
Good, negative 3.
To x to the fourth, y to the 8, to the
That's a z.
z, z.
Z to the fifth. Good. That was a tricky one. I wanted you to see one where there was no number as the coefficient so that you knew to multiply by negative 1. Okay, let's do 11 together also. Let's see, Maddie, you can do me well.
Negative 2x to the 6th power.
Good.
Y to the 2nd power.
Good.
Z to the 5th power.
Good. Very good. Okay, your homework is to finish this sheet so you can refer back. These are kind of selective samples of what the other problems are going to be like, so you can look back to do them. As you work on this, you can compare, once you get all your answers, compare with someone else to see if you guys all got the same things. If not, you can spend some time trying to figure out what your mistakes were.
We're doing the whole sheet?